All right. Well, hello everyone. Thank you for being here. The title of this talk is "The Future of Infrastructure Will Be Containerized." This is not really a technical talk. This is more like inspirational, if you want. Just me rambling for 40 minutes about my past and how things used to be cool. Because as you grow up in the tech industry, you become a grumpy person who thinks that the new people don't know what they're doing, and that's what you were doing 20 years ago was better. But also looking at the future, right? I'm personally, it's not somebody who is like into hype in technology in general. I don't like to follow what's going on all the time. I'm a firm believer of if it works, don't fix it. But it's also important to keep an eye on what's going on around us as technologists, right? And this is just 45 minutes, 40 minutes, 30 minutes, however this takes, summary of what's going on. My name is Abdel. I'm a cloud developer advocate at Google. I've been in the industry for almost 15 years. I've been at Google for 10 years. I'm actually based in Stockholm. I started my career in a very unconventional way. I have a master's in software engineering, but I actually never worked as a software engineer full-time. Right after my master's, I went straight and worked in a data center. How many people here have ever worked in data centers? Wow, one person. Okay. So you're probably the other grumpiest person in the room, just kidding. I get a lot of confirmation. So this was back home where I'm from in Morocco. I joined the company, which basically was hosting servers. And by hosting servers, I don't mean like web hosting, as you know it, actually physical hosting, like physical servers. So we were renting out rack space and switches and stuff like that. This whole, coming from this background, it gives me kind of a different way of looking at things when it comes into like how this industry is progressing, because being so close to low-level hardware gives you a different appreciation for all the new technologies that we are using, especially containers, obviously. But it's also saddening a bit in the sense that I'm realizing that the more we're progressing with all these new technologies coming around us, the more people are abstracted away from low-level stuff, and the more people are brought up in our industry not having a deep understanding of how stuff works. And I was having a discussion this week with somebody, and I was telling them that I'm thinking of creating a talk next year that I'll be submitting to conferences called How the Internet Works. You will be very, very surprised how much people don't know how the internet works and how DNS works and how like very, very basic stuff. But anyway, enough being grumpy. I co-host a podcast called Kubernetes Podcast, and I'm also a CNCF ambassador. 2013, in PyCon, Docker was revealed by, I forgot the name of the guy, Solomon? Solomon is his name? So Docker was revealed as the first way to make containers. Containers in Linux existed for a very long time, or at least the primitives inside the Linux kernel that makes containers exist as we know them today are not new. Things like C groups and network namespaces and chroot, and these are the main components that makes Docker do what it does, existed in the Linux kernel since version 3.x. So what really Docker did is it made containers easy for everyone. It made it suddenly very easy to start from a very simple text file called a Docker file, writing a bunch of instructions, and then running this instruction through a command line, which will generate an image that you can run as a container, which is simply just a process inside the Linux system, right? And just as shipping or as containers did for the global kind of supply chain industry, containers did the same thing for our tech industry. What shipping containers made easy for global shipping is standardization. Suddenly, it was easy to take this standard size called a container, which is usually a full or a half, shove whatever you want inside, and then it becomes easy to transport that unit because it's easy to stack on top of a boat, it's easy to carry inside the ports, it's easy to put on a track, and it's easy to bring to its destination. So containers actually did the same thing for the software industry. Containers makes it easier to take whatever software, whatever dependencies, whatever configuration file, and just shove them inside a standard thing called a container image. Later on, because the emergence of container with Docker, a bunch of other companies like CoreOS, for example, which doesn't exist anymore, it was purchased by Red Hat at some point, came and said, well, we want to do our own container engine. We don't like the way Docker did it. And then a bunch of other companies and people started kind of wanting to do the same thing. And then suddenly, the industry realized we need standardization, right? So they sit down and they created what they call the OCI, the Open Container Initiative. And the Open Container Initiative is basically ISO for containers. It's just a standard. It's just a bunch of people sitting together and agreeing what a container image should look like, how a container is supposed to be run, and how a container lifecycle is supposed to be managed. And then today, you can basically take Docker, you write a Docker file, use the Docker command line to write a container, take that exact container and use something like containerd, the CRI CTL. How many people know about containerd? Few people. Okay, so containerd is just a container runtime, right? So you can take containerd, which its command line is called CRI CTL, and run that container that you created using Docker because of OCI, because OCI is the standard, right? That actually prompted like a huge change in the way people do things. And I'm giving these 3 examples because they are very good examples of 3 companies in 3 different industries, but they all have a shared common faith. They are old companies. They existed for a very long time. They probably had mainframes and probably still have mainframes. So L'Oreal, I forgot the name, cosmetics company, French one. They started using containers to process 20 terabytes per month using serverless on GCP, but it doesn't matter. The Home Depot, they actually made their in-app purchasing experience better with containers because suddenly they could quickly reiterate and do things faster because they can get code changes from development to production very quickly. The one that is closer to home is PGS. PGS is a Norwegian company. They do deep sea exploration for oil and gas, and they also do collect information about the atmosphere. So they have these both. They are very cool. They have these vessels that look like a shipping vessel, but it looks like a shipping vessel that have been cut. So it's just the front part of the shipping vessel where the captain is. They go inside the sea and then they drop those long cables with sensors and they drag them through the seabed looking for pockets of gas and oil. And they collect a bunch of other information about sea temperature, the weather, etc. And then because these vessels go out in the sea for months at a time, they can't actually have, they don't have reliable internet. They have satellite internet, which is not very fast and not very reliable. So they store all this data on the vessels, and then they bring it back home, they offload the data, and then they process it in an HPC, a high-performance computing. In 2020, when the world went to hell because of COVID, they were actually about to renew all their HPCs because they were end of life. And if you know anything about HPCs, or if you don't know, they are super expensive machines. They cost millions and millions, or hundreds of millions actually to purchase and operate. So they had a very big bet saying, okay, we're not going to purchase new HPCs. We're just going to do everything on Kubernetes. To some of you, that might sound wild. If you really think about it, what an HPC does is just distributed computing, right? On specialized hardware with specialized networking, but it's still just distributed computing. So just batch processing, right? So they bet on Kubernetes. GKE, doesn't matter. They bet on Google Cloud. They could have bet on Amazon or Azure. It would have been the same outcome. What they did actually, they spent some time building abstraction layers that allows their data scientists to still use the same tooling. Just instead of running those computation on HPCs, they would run them on a different target environment, which is Kubernetes. And at peak, they ran 1.2 million cores. I'm going to pause a second for you to appreciate this number. It's 1.2 million vCPUs. It's a lot of money. Few hundred terabytes of data, few hundred terabytes of memory. And now, or at least a year ago, when I interviewed one of their principal architects for the Kubernetes podcast, they were looking into actually putting Kubernetes on the vessels so they can do some pre-processing as they are collecting the data, so they can clean the data on the vessel before they get it back to the shore and offload the data. All of this because of containers, because suddenly we could do things in a way that we couldn't do it before. So let's take a step back and talk about where containers came from. And this is what I like to call, again, being a grumpy person, this is what I like to call how things used to be and why we cannot have nice things. Or sometimes I present this as the history of software deployment. How did we deploy software before and how we do it today? A very long time ago, we started doing things called bare metal. We take a server, and we shove a bunch of software on it, plus the operating system, plus the configuration files. Then suddenly, 25 years ago, virtualization became a thing, where suddenly we realized we could actually take a physical server and virtually split it into small servers, right? By allocating hardware and software into small units called the virtual machine. The virtual machine is still a full operating system server. It still has a kernel, it has an operating system, but suddenly, at least, you could A, better utilize your hardware by running multiple virtual machines on the same hardware, and B, theoretically, makes it easier to standardize if you can make your developers produce a virtual machine as an artifact instead of a binary as an artifact. And then you could hopefully avoid the "it worked on my laptop" problem, right? Then containers came in 2013, 10 years ago. And containers, what the beauty of containers is that they can run anywhere. You can run them on a virtual machine, you can run them on bare metal, you can run them on Raspberry Pi, you can run them on your phone. I have even seen people doing containers on PlayStations because they're just Linux boxes, so you can run whatever you want on them. And they made this problem of it ran on my computer kind of go away, because suddenly as a developer all you have to produce is a container. It's lightweight, it starts very fast, you can scale it up and down very fast. It's reusable, it's shareable. You can actually give your container to somebody else, which they can start from an already existing container and then build on top of it, add stuff to it. So they are inherently, they come with a bunch of inherent built-in features. Since they are short-lived and frequently updated, containers are technically easier to patch. If you suddenly have a new vulnerability and you want to roll out a new patch, you can just release your patch and just restart your containers, and then restart your running processes, containers as just processes, and then the containers will just pull the new image and run the new patch, right? That's compared to like running on top of a server, where if you were doing Java 20 years ago, you have to like produce a jar file, SSH into a server, copy the jar file into the server, and then restart your WebSphere server or whatever. How many people here done WebSphere before? Okay, a few people. All right, cool. So everybody here is young. That's cool. All right. They are immutable. Immutable means that a container, when it's running, it cannot be changed, it cannot be modified, and you can easily re-establish or reset the state of the container by just restarting it. So that comes in with an inherent security feature. It's not completely secure. There is one thing actually that is really bad from a security standpoint about containers, is that they don't contain. A container by default because it does not contain an operating system and the kernel, basically all the syscalls that your application is making to the operating system are still executed on top of the shared operating system on the host, right? If you need to open a file, if you need to connect to the network, you're still using the kernel of the host to execute all these operations. So that's why I always say containers doesn't contain, so they don't isolate your process. Your process is not running in a vacuum. It still depends on the operating system. You can add isolation technologies. There are a bunch of examples. Like there is this whole genre, and I'm going to just mention it very quickly. There is this whole genre, and by genre I mean group of tools that tries to like marry containers and virtual machines. They call them micro VMs, and that's where you have things like Kata containers or what's the AWS one? Firecracker. So if you are running on top of AWS Lambda, because AWS cannot trust your code because it's not code written and tested by AWS, they cannot run your code inside the container in Lambda or in Fargate or whatever. So the way they do it is that they actually wrote what they call a micro VM. So a micro VM is a container that has the isolation properties of a virtual machine. So it still have a mini kernel and the processes run in the user space. It's called Firecracker, it's open source. So they can at least make sure that if they take third-party code, which is your code, and run it on top of a shared host, they have some guaranteed isolation between the processes, right? This is just one example of Firecracker. There is Kata containers, which I think now is part of Microsoft. Google has something called gvisor. So these isolation technologies that just emerged over time to resolve the isolation properties that containers doesn't have are good to be able to have the benefits of a virtual machine but also without the drawbacks of a virtual machine and the benefits of containers, but without the security drawbacks of containers. Come on. Yeah, so we talked about it. It worked. We avoided the problem of it worked on my machine. So the problem now, or the issue, is that as we're going forward, your life as a developer is only going to become more complicated. When we were in the bare metal space, all you had to do is write code, right? And you were probably lucky you had a team called sysadmins. You remember these people? You just like ship your code to these people, and then it's their problem, right? It's not a problem as a developer. And well, it's not technically your problem because they will most probably come back to you yelling about the fact that you used a new version of the library that they don't have in the server, and then you have to go back to the old version of the library because your new version of the library is only compatible with your application and not with the other application of the other people, blah, blah, blah. So then we progress toward platform as a service. Actually, all of these like virtual machines, running on somebody else's code, I call that the early cloud platform as a service kind of things. Things like Heroku, things like App Engine. Then suddenly, as a developer, you were empowered to actually do everything yourself. But then you actually have to learn more things. Well, you have to learn cloud. And then you have to learn this thing called Heroku or App Engine or whatever it is. Or you have to learn Kubernetes, right? Or you have to learn whatever that thing, whatever that technology you are using that allows you to do everything yourself without having to hand off your code to somebody else is suddenly your problem because you have to learn it, right? And then as we are progressing, things are only going to get more complicated because now there is security, and you have to make sure that your code is safe. And then you have to make sure you are not using vulnerable libraries. There is scalability, et cetera, et cetera. I guess what I'm trying to say with this long monologue is DevOps, right? We used to be developers. We write code and run it to give it somebody else to run it. Now we're not doing that anymore. We're all kind of one flavor of another of DevOps, or even worse, probably, or one flavor or another of a full stack engineer. Which, how many here are full stack engineers? Okay. There is more people in this room claiming to be full stack engineers than there are actually in the world. I'm just kidding. I mean, I'm not trying to say that you are not doing the right thing. I just don't understand full stack engineers as a concept in general. Because there are probably 9 developers in the world that can write code, front ends and back ends, configure databases, optimize them, configure caching, do automation, write Terraform code, secure all your system, and then still make a coffee. And also the way we are doing development is getting more complicated as we are progressing, right? Usually, if you are working in an industry where you are producing software for somebody else, and by working in an industry where you're producing software for somebody else, I mean 75% of the industry. The big tech company, the big people, the Google and Facebook and all these people of the world, they are in a sort of league of themselves because they have fully integrated teams, right? A company like Google, the way software development works inside of Google is that your customer is your product manager, the people who are in charge of your products, the product owner, product manager, whatever you want to call them. They are the people giving you the requirements. You write that code, you test it, you're responsible for the entire full cycle of the code, and then you just hand it off to a team called typically an SRE, a site reliability engineering team, who is responsible for production. But if you're doing software development in a company that does consulting, for example, or that produces a software that external people use, you start with the customer. The customer gives you requirements. That goes through a design analysis phase, and that's typically done by the line of business. So that's the product owner part. Then it gets approval. Then we have the release and planning and estimation part, aka project management. People who are responsible for saying this feature will require this number of weeks to be produced, and it will cost this amount of money, and it will be done by this person and this person. Then it gets to the development and testing. So that's the real engineering part of all of this process, right? Then it goes to QA, which is still part of engineering. Then after that, it goes probably to testing. And then from there, it goes to production. And then in production, you have a feedback cycle, hopefully, where you detect bugs, and then you go back to the developers, and you continue the cycle. This is just all a very long way to say that doing software development today is complicated just because somehow the industry adopted all these steps that from a requirement to a final product, we have a bunch of people, teams, processes involved to make the development process more agile, or whatever they call it. So this means that if today you're working somewhere where you are looking at adopting containers, you have to follow, again, a certain process. And this process will be complicated for sure. But I'm here to give you these 5 or 4 things, which is how are you looking at adopting containers? Starting with finding the right platform, finding the right abstraction layer. I don't know if you heard about this or if you were under a rock in the last 10 years, but there is this whole genre thing called platform engineering, platform thingy, whatever, which is just like a modern interpretation of DevOps. Again, the tech industry is extremely cyclical, something that is like something that is some stuff that people are looking at today existed 20 years ago, and you just keep reinventing the wheel. If you are amazed like myself by all the AI stuff happening these days, we did AI 15 years ago, spam filtering in email, that's AI based. We had AI, it's not new. If you are looking at things like, I don't know, I want to stop rambling. I have a reputation of being grumpy a lot. Go to my Twitter, that's where I'm doing that. Anyway, so if you're looking at this like whole platform engineering thing, like creating a platform, or if maybe you're discussing this inside your teams, like we have to have a platform because that's what the new kids in the block are doing, right? Like, do you notice the little dotted line in the middle? Does that sound familiar a little bit? What does it, somebody? Just shout out. What does that sound like? Isn't that going back to developers and sysadmin, right? Sort of. Isn't that what DevOps was supposed to solve? Like, demolish this virtual wall between production and operations? Well, with platform, it sounds like we're just going back to doing that, actually. Just going back to pre-DevOps era, where you have people on one side, on the left side, doing the platform part, which is building abstraction layers to theoretically make your developer experience better. And then you have people on your left side, my right side, or no, your right side, sorry, doing the development part, right? So writing code and then using whatever the platform engineering team provides them to use. And we're creating all these, again, processes and complicated way of doing things because they're supposed to improve the development experience. I spoke to, as part of the podcast that I am co-hosting, I interview quite a lot of people. And I had this very funny conversation a few weeks ago. I talked to NAV. NAV is, for those of you who doesn't live in the Nordics, they are the Norwegian Wealth Fund, the pension and healthcare of Norway. It's a public institution, it's an agency. They built an abstraction layer on top of Kubernetes called NICE, N-A-I-S, it's written in NAIS.io. It's essentially just abstraction layer on top of Kubernetes. It allows you to deploy apps of Kubernetes on an easy way. You just write a very simple YAML file instead of like very, very long YAML files. And then it just goes through like an engine and generates the low-level Kubernetes objects that you as developers shouldn't care about. And during our interview, we were discussing this platform engineering because technically NICE is a platform, right? The tool acts as a platform. And I was asking them the question of like, so, because I'm genuinely curious about this whole platform engineering space, about when your developers need a new feature, how do you go about implementing it, right? Say you have a platform, you have a bunch of people taking care of the platform, and you're a developer. And suddenly you want to do something. You want to use a new tool, you want to use a new system, you want to develop a new feature, and then there is a framework or there is a tool that can allow you to do that in an easy way. How do you go about implementing that? Do you implement it yourself as a developer? Or do you push back that down to the platform and have the platform people implement it for you, right? Genuine question? Fair question, right? So I was asking them this, and they were like, well, actually, we realized over the years that 99% of our developers needs the same thing. So no one really cares. People just want to write code, have the code work, and then go home to their kids. Which is a very interesting answer in the sense that what this whole platform thing makes it look like, it makes it look like it's complicated. It makes it look like the infrastructure is so complicated that we need a dedicated group of people to be in charge of it, right? While genuinely on every single cloud provider, there is already a platform. There is already something called Cloud Run on Google Cloud. There is already something called Fargate on AWS. There is already something called ACS, Azure Container Services on Azure. There is already a thing taking care taken care of by the cloud provider that you can just use, and it just works because 99% of your needs are similar to all the needs of all the other developers. I want to write a backend, a front end, I need an API, I probably need an API gateway, I need a database, and I probably need a publisher subscriber, PubSub, MQTT, Kafka type thing, right? Does that meet most of your needs? Raise your hand if it does. Right? Okay, so we agree that no one needs platforms? Good, right. But let's keep it here, because we're gonna make people unhappy. Anyway, so yeah, I talked about this, right? This is what we have in Google Cloud, but every single cloud provider have the same. Everybody has Kubernetes, everybody have some sort of serverless containers, everybody have some sort of serverless functions. We call them this on Google Cloud. They call it EKS, Elastic Container Services, or Kubernetes Services, Fargate, Lambda on AWS. Then they call it AKS, Azure Kubernetes Services, ACS, Azure Container Services, and whatever functions they call them on Azure, cloud functions, right? Azure functions. So everybody has the same thing. Everybody pretty much provides the same like tooling. So just use whatever the freaking cloud provider gives you. Don't complicate things. In 2014, Kubernetes was released. There's actually a funny story. Do you folks remember Docker Swarm? Everybody remembers Docker Swarm? What it is? It didn't take off, right? It kind of died. You know why it died? Because it was actually announced at the same conference as Kubernetes. It was announced at the same exact conference. So it was DockerCon, and we went to, so there is a typo in the slide. It says DockerCon, it's not KubeCon. KubeCon did not exist before KubeCon was released. Anyway, it was at DockerCon, Google was invited, and we went on stage and we announced Kubernetes at the same time that Docker announced Docker Swarm. Two tools trying to do the same thing got announced at the same time. One picked up and one died. And what Kubernetes was released to be, it's an open source, container-based, on Docker system. It's essentially an operating system for the cloud. It's an abstraction layer on top of compute. That's what it was supposed to be, and that's what it is essentially today. It's just a tool that takes a bunch of VMs, servers, Raspberry Pis, phones, PlayStations, and just make them look like one gigantic computer accessible through an API. That's it. That's in a nutshell what Kubernetes is. How would you go about achieving speed without sacrificing stability? Well, there are multiple ways you could do that. These are here, what you look at here is the research. There's this thing called DORA. DORA is the DevOps Research and Assessment. It was a company that Google acquired at some point, and what they actually do is they produce methodologies, because that's what all DevOps is a set of methodologies, is a framework. So they produce methodologies, and all the methodologies kind of center around these four things. And the whole point of DevOps is trying to balance speed and stability, trying to balance how fast you are actually releasing features with how stable your system is. In the speed pillar, you have the deployment frequency and the lead time for change. So how frequently do you deploy your application, and how fast you are getting your changes from the development all the way until production. These are two different things. The reason why there are two different things is because getting changes made by developers is easy, if you want it to be easy. But you can get developers to release changes very quickly. But how fast can you get those changes into production is a different measure. It's a different thing that you have to also assess and look at. One is an indication on how fast your developers are able to reiterate and build new things. And one is a measure of how fast you can get these new things to actually be deployed. On the stability part, you have the time to restore the service, which is how fast it can take you to go back to like a functioning system when things go inevitably wrong. And then the change failure rate. What's your success changes divided by your failed changes, essentially, right? So these two measures are very important for any successful development team to track, to be able to see per month, per week, per year, per quarter, how fast are we able to push things out. And these are things that come through your development experience. How fast can people get the feedback loop? How fast can developers build things, ship things, and then get back bugs or success criteria? How fast? It's actually one interesting thing. I'm a big fan of psychology, and I read a lot of psychology books. And a lot of times when, I worked as a developer at some point, but like very briefly. A lot of times when you are a developer working in a company, the only metric you are getting back is bugs, right? You're never fed back from your system what's your success rate. You're always fed back your bugs rate, like how fast you're introducing bugs into your system. And you're never told, oh, this change you have made us onboard 20,000 users, right? Or probably these kind of things are shared in all hands meetings with the CEO that no developer goes to. So managing efficiency while continuing to innovate. There is this whole thing now called FinOps, financial operations, cost optimization. It's becoming a big deal. How fast can we, how good can we utilize what we have instead of just throwing more CPU and memory at the problem to try to make it go away? And there are people, there is like a whole FinOps movement with people and tools and systems that are put in place by companies and organizations to try to figure out how much are we spending on our IT versus how much of good value are we getting from it. But as developers or as tech people, we care about the right side. We care about, are we actually writing or using the same, or like utilizing our resources better? Are we upsizing our apps? Or are we just deploying our apps with 6 GB of memory, but only using 2 all the time? Are we able to scale down during low demand and scale back up when we need it fast? And are we actually able to pack apps properly in an optimal way on top of existing hardware, existing tools we have? And the last thing I want to talk about is that a lot of times when people talk about containers, they just think that containers are just for stateless, right? Just because they are fast to start, fast to restart, fast to patch, they should only be used for stateless apps. Running databases in containers, that's dangerous. That's actually not true. The Kubernetes specifically have invested very, very heavily in making stateful apps a first-class citizen in the system. That's because now we have to do AI and ML, and AI and ML are stateful apps, and we have to somehow make them work. Kubernetes is extremely portable across multiple environments, including on-prem. So investing in actually transforming your apps to be Kubernetes compatible is one of the probably closest we are going to get to this word that I really hate, vendor lock-in or vendor locked out. I really don't like the word, but this is probably as close to that as you can get. Being able to run apps on Kubernetes could, to some extent, guarantee portability. And I say to some extent between quotes, because it always depends on what else around Kubernetes do you actually have, right? And if you're wondering why I really hate the term vendor lock-in, because again, I'm a grumpy person, is because whenever people talk to me about vendor lock-in, my first question to them is, what do you use to write your apps? I use insert programming languages, .NET. Okay, let's say that tomorrow Microsoft goes, every single person using .NET to write an app that makes money have to pay us licenses, right? These have happened before with other companies without mentioning names. So the question is, how fast are you going to be able to migrate your app from .NET to Go? Anybody in the room, go, give me a number. Just random, shout a number. Sorry? A year? Okay, you're already vendor locked in. Another person? For at least a year. Somebody else? 1,000,000 years, thank you. So you're already vendor locked in. You're already vendor locked into the programming language you're using. You're already vendor locked into the tooling you're using. You're already vendor locked into the computer you're using. I am a Mac user. I don't think I can be productive on any other operating system. I used to be a Linux user for a very long time. I was very productive on Linux. Switched to Mac, my productivity dipped and then kind of went back up, and now it's kind of stable. And I know that if I have to switch to Microsoft Windows or back to Linux, then my productivity will again dip, because I'm just not used to it, right? So I'm already vendor locked into whatever I'm using day to day, whether I want it or not, period. So the term vendor locked in is just an overloaded term, like serverless and cloud. What about security? And how am I doing on time? 4 minutes? Holy shit, okay. I talked about this yesterday in my talk. Software supply chain security is becoming a big problem. You have to look at your build system. You have to look at your delivery system. You have to look at all of these things. You have to make sure you're not going to shoot yourself on the face. I'm not going to talk any further. The talk will probably be online, or just look me up, Abdellfetah Software Supply Chain Security. There are a bunch of videos on the internet. I want to talk about something that is kind of closer to my heart. This is the thing I am actually keeping an eye on. Have you heard about WebAssembly or WASM? Cool, do you know what it is? More or less, okay. So what it is, WASM was a thing that we used to run in browsers. It was a way for people to write apps in non-JavaScript code and have it natively run in browsers. Why you want to run non-Java code in browsers? Because you need non-Java code to access things like microphones, to access things like graphic cards, camera, blah, 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 because JavaScript is not fast. So WASM, what's happening recently is that people are trying to take WebAssembly outside of the browser as a way to write backend code. The thing with WASM, which makes it actually good for backend code, is that WebAssembly is runtime. And every single major cloud programming language today can actually compile toward WASM as a binary format. So with WASM, you have a runtime that you can deploy on your operating system, and then you can write your app, compile it once, and then run it everywhere. It's just a JVM reinvented, essentially. So I'm going to leave you with this, just because I don't have time. This is what the future looks like, in my opinion. We did hardware, then we did VMs, then we did containers. Now we're in containers. We're going probably toward WASM in the future, because hopefully, hoping that WASM and WASI and WAGI and all these kind of like things that are being undefined, that are being defined right now as we're speaking, aka standards, will get resolved at some point. That's it. Thank you very much. I hope it was useful. Nice. So it was 10. I was supposed to stop at 10. Okay. Do I have 1 minute for questions, I guess? Yes. Very good point. Yes, as long as your platform is portable itself, right? Correct. But as long as, yes, I agree with you. The problem that the way I see people implementing platforms these days is that it's not only about compute, because sometimes your platform will also have a vendor-specific feature in it. Right? In that case, you're not going to be able to be portable. Let's just take an example of Google Cloud. If your platform provides you with Spanner, Spanner is just a Google database. It doesn't exist somewhere else. But yes, theoretically, yes. As long as your platform only requires computing or compute, everybody has compute. So it's theoretically portable. All right. I hope my rambling was not too much. Thank you.